simultaneous event actually depend on the position of the observers. Now we consider the time dilation. The source of the light is located near the end of one of the walls. Then light is moving to the ceiling and reflected and return to the source of the light. The girl sees the light is reflected on the ceiling and come back to the original position. In the 2D is the total distance for the light to travel, divided by the speed of light. Then this is speed of light. Okay, delta t prime is a 2D over c. We call it this is proper times. Proper time is the time interval between the two events that occurs at the same point. This is really important. For the girl, two events happen at the same point. So delta t prime. We call that this is proper time. And then the boy observes the same event. For the boy, the source of the light is moving to the light with a train. Source of the light is located here. And then train is moving to the light. This is the path of the light to follow, to return to the source of the light. Then you can create the triangle. This triangle. This length is a d. This length is gonna be b times b is the velocity of the trains. Delta t over 2. During the delta t over 2, train is moving to the right with this length. And this light is traveling c times delta t over 2. Then we have this triangle. Then we applied Pythagoras theorems. Pythagoras theorem. From this equation, you can calculate delta t is obtained 2d over square root c square minus v square. It's very different from the delta t primes. At least the equation, form of the equation is very different from the equation for the proper times. So for the girl, light to return to the source of the light is the delta t prime, 2d over c. For a boy, same event is observed by a boy. It takes the delta t, 2d over square root c square minus b squares. If you take a ratio of the delta t prime over delta t, it's equal to the square root 1 minus b over c squares. This is a positive quantity, so should be less than 1. So this means delta t prime is smaller than the delta t. For a boy, it takes a longer to observe the same event. So this means the clocks of the boys delays with respect to the clock of the girl. So this is time dilation. Suppose two events occur at the same point in space. Time interval between these events as measured by an observer at rest, the rest frame. This is the time for a girl. Is a proper time, delta t prime. An observer in the second frame, moving with constant speed v relative to the rest frame, measure the time interval delta t. This is the time interval for a boy, as delta t equal gamma delta t prime. And the gamma is defined in this equation. So delta t is always larger than delta t prime. Observer measures any clock to run slowly if it moves relative to them. This is a very, very strange world, but this is the result. if we accept the two fundamental statements of the special relativities.